Let's get right into it. Science fiction loves the idea of humans born in space, kids raised on Mars colonies, starship captains who've never seen Earth. It all sounds very noble and adventurous. But science fiction, bless its optimistic heart, tends to skip over the messy, inconvenient, and frankly horrifying biological details. It treats the human body like a piece of software that can just be installed on a new planetary hard drive. But our bodies aren't software. They're hardware, meticulously designed and calibrated by one thing and one thing only, a constant, unforgiving 1G pull towards the center of a planet. Take that away during the most critical developmental phases, and you don't get a heroic star child. You get a biological catastrophe. So what would really happen if a human was born and raised in zero gravity? Let's peel back the sci-fi fantasy and look at the brutal biological checklist. Your skeleton feels solid, permanent, like the frame of a house. But it isn't. It's a dynamic living system, constantly breaking itself down and rebuilding, like a road crew that never goes home. This process is governed by a simple, elegant principle called Wolff's Law, which basically states that bone adapts to the load it's under. The more you stress it, the stronger and denser it gets. Every step you take, every time you jump, every time you just stand there fighting the planet's relentless pull, you are sending a memo to your osteoblasts, your bone-building cells that says, hey, we need to be stronger. Reinforce the girders. This is why astronauts on the International Space Station have to exercise for 2 hours a day. They're desperately trying to replicate that stress. And even with cutting-edge resistance machines, they still lose 1 to 2% of their bone mass per month in key areas like the hips and spine. After a 6-month mission, an astronaut can return to Earth with the bone density of someone decades older. Their body, floating in space, decided that a strong skeleton was just dead weight, an unnecessary expense, and started aggressively downsizing. Now imagine a fetus developing in that environment. From the moment of conception, its body would never receive that fundamental signal. You need to be strong. It would have no reason to build dense, robust bones. The genetic blueprint is there, sure, but the instruction to actually execute that blueprint with any kind of urgency is missing. The baby's skeleton would form, but it would be a ghost of what it should be: porous, light, and terrifyingly fragile. If this zero-G human, let's call him Cosmo, ever tried to visit Earth, he wouldn't just have to get used to gravity. His entire skeletal structure would be put under a load it was never, ever designed to handle. The simple act of standing up could fracture his femurs. A friendly handshake could shatter the delicate bones in his hand. His spine, which never had to support the weight of his own head, would compress catastrophically. He wouldn't be a visitor, he'd be a living porcelain doll in a world made of hammers. His first breath in a gravity well would be the beginning of his body breaking itself apart. How do you know which way is up? It seems like a stupid question. You just know. You feel it. But that feeling is a complex piece of engineering. Deep inside your inner ear, you have a sophisticated biological accelerometer called the vestibular system. It's a series of fluid-filled canals and tiny dense crystals called otoliths. As you move your head, the fluid sloshes around and the crystals shift, brushing against tiny hair cells. These cells send a constant stream of information to your brain about its orientation in three-dimensional space. It's your personal, squishy gyroscope, and it's been telling you where down is since before you were born. When astronauts first get to space, this system goes haywire. The otoliths, no longer pulled down by gravity, just float. The brain is suddenly hit with a fire hose of nonsensical data. The result is space adaptation syndrome, or space sickness. About half of all astronauts spend their first few days in orbit feeling profoundly dizzy, disoriented, and nauseous as their brain struggles to make sense of the conflicting signals from their eyes and their ears. Eventually, the brain does something incredible. It starts to ignore the inner ear almost completely and relies solely on visual cues. The floor of the station is down, the ceiling is up. But this is an adaptation, an adult brain rewiring itself. Our hypothetical Cosmo kid wouldn't be adapting. He would be developing. His brain would never, not once, receive a coherent down signal from his vestibular system. The neural pathways that connect that system to the rest of the brain, the ones responsible for balance, spatial orientation, and coordinating movement, might be severely underdeveloped or wired in a completely alien way. He would be perfectly at home in zero-G, gracefully navigating his environment using only his eyes. But bring him to Earth, and his brain would be assaulted by a fundamental force it has no framework to understand. The constant, unwavering signal of gravity from his inner ear would be a deafening, incomprehensible roar. He wouldn't just feel sick, he would be incapable of balance on a profound level. He wouldn't be able to stand or sit, or even tell if he was lying down or hanging upside down without looking. The world would be a permanent, swirling, nauseating vortex. It would be a sensory nightmare from which there is no escape, because the nightmare is coming from inside his own head. Here on Earth, your body is in a constant, hidden war with gravity, and your heart is the general leading the charge. It has to work significantly harder to pump blood up to your brain than it does to let it flow down to your feet. Your circulatory system is full of clever valves and mechanisms designed specifically to manage this top-to-bottom pressure gradient. The moment you enter zero gravity, that entire system is thrown into chaos. Without gravity pulling everything down, your bodily fluids, all 10 gallons of them, immediately shift upwards. Blood and water that would normally be in your legs pools in your chest and head. This is why astronauts in photos often have slightly puffy faces and swollen sinuses. They're literally waterlogged from the chest up. It also gives them what they call bird legs, as their lower extremities lose that fluid volume. But this isn't just a cosmetic issue. The body, ever the literal-minded machine, interprets this fluid shift as meaning it has too much blood. It panics, thinking you're overhydrated, and triggers a whole cascade of responses to get rid of this excess fluid. It makes you feel less thirsty, it signals your kidneys to produce more urine, and over time, it lowers your overall plasma volume. It even reduces the production of red blood cells, a condition known as space anemia, because delivering oxygen is just easier when your heart doesn't have to fight gravity. Your body is efficiently recalibrating itself for an environment where its plumbing doesn't have to work so hard. For our spaceborne child Cosmo, this isn't a recalibration, it's the factory setting. His heart would develop as a low-pressure, low-demand pump. The very muscle walls would be thinner. His total blood volume would be significantly lower than a terrestrial human's. He would be perfectly tuned for a life of effortless floating. The second he entered Earth's gravity, that elegant adaptation would become a critical failure. The moment he was placed in an upright position, the gravity he never knew would grab hold of his low-volume blood supply and pull it down into his bird legs. His weak, inexperienced heart would be completely unable to pump it back up to his head. This is called orthostatic intolerance, and it's something returning astronauts have to fight against constantly. For Cosmo, it would be absolute. He would faint, instantly, every single time he tried to stand up. His life on Earth would be a horizontal one, his cardiovascular system a monument to an environment that never asked it to try. Pushing a multi-ton piece of equipment across a room on the International Space Station requires about as much effort as nudging a balloon. Locomotion isn't about strength, it's about controlled, gentle pushes off of surfaces. In this world, the biggest, most powerful muscles in your body, your quads, your glutes, your entire posterior chain, are basically useless. Their primary, day-to-day job on Earth is simple. They are your anti-gravity muscles. They keep you standing. They are the biological scaffolding that prevents you from collapsing into a heap on the floor. In zero-G, this scaffolding is unnecessary baggage. The body, being a ruthless accountant of caloric energy, sees these giant, metabolically expensive muscles and immediately marks them for liquidation. This process is muscular atrophy. The body begins to actively break down the muscle tissue, scavenging it for proteins and energy. It's a use it or lose it principle on hyperspeed. Astronauts know this well. Their 2-hour daily exercise regimen is a desperate, ongoing battle to convince their bodies that these muscles are, in fact, still needed, and it's a battle they only partially win. They still come back to Earth significantly weaker, having to go through weeks or months of physical therapy to relearn how to walk and carry their own weight. Cosmo wouldn't be fighting atrophy. He would be the embodiment of it. He wouldn't lose muscle mass. He would simply never have built it in the first place. His muscles would have developed to be just strong enough for the gentle pushes of a zero-G environment. His legs, which for a terrestrial human contain the largest muscles in the body, would be spindly, underdeveloped appendages. The very composition of his muscle fibers would be different, likely favoring fast twitch fibers for quick, short movements over the slow twitch fibers needed for endurance and posture. If he were brought to Earth, he wouldn't just feel weak. He would be functionally trapped by his own body weight. He might lack the basic strength to lift his arm against the pull of gravity. The act of sitting up in bed would be the equivalent of a heavy weightlifting session. Walking would be an absolute impossibility. His body wouldn't be sick or broken. In fact, it would be a perfect specimen of peak efficiency. It's just that it would be efficient for a world he could never return to, leaving him a prisoner in the one he just entered. In 2005, astronaut John Phillips launched to the International Space Station with perfect 20/20 vision. When he landed back on Earth 6 months later, his eyesight had degraded to 2100. Another astronaut, Scott Kelly, spent nearly a year in space and came back describing changes to his vision too. For years, NASA treated these as isolated incidents, but the reports kept coming. Astronaut after astronaut returned from long-duration missions with blurry vision. It was a genuine medical mystery. What was space doing to their eyes? The answer, it turns out, is linked back to that same fluid shift that gives astronauts puffy faces. That upward migration of bodily fluid also slightly increases the pressure inside the skull. Here on Earth, the pressure inside your cranium fluctuates. When you lie down, it goes up. When you stand up, gravity helps it drain and it goes down. It's a dynamic rhythm. In space, that rhythm is gone. There's just a constant, low-level, elevated pressure. 24 hours a day, for months on end. This relentless pressure literally begins to squash the back of the eyeball. It can cause the optic nerve to swell, create folds in the retina, and physically flatten the shape of the eyeball itself. They even gave it a name, Spaceflight-Associated Neuroocular Syndrome, or SANS. It's a physical deformation of the eye caused by the absence of gravity. For an adult astronaut, this is a condition that develops over time, and for many, it's reversible. But Cosmo wouldn't be developing SANS, he would be developing with it. His eyes would form from infancy under this abnormal, constant pressure. The very shape of his lens, the curvature of his retina, the connection of his optic nerve, all of it would be calibrated to this warped environment. His brain might learn to interpret the signals from these misshapen organs, but he would have a fundamentally different model of vision. If he ever came to Earth, the sudden decrease in intracranial pressure wouldn't necessarily snap his eyes back into a normal shape. The changes could be permanent. He'd arrive on a vibrant, living world that he could never truly see. The faces of the people greeting him would be a blur. The horizon, the clouds, the moon, and the night sky all would be rendered as an impressionist painting by eyes that were physically sculpted by the void. Your immune system is not a wall, it's a library, a vast, violent, and incredibly intelligent library of every pathogen you've ever encountered. From the moment you're born, you are plunged into a chaotic biological soup. Every speck of dust, every gust of pollen, every handshake, every common cold is a new entry into the catalog. Your immune cells learn to recognize the enemy, create antibodies, and, most importantly, remember. A strong immune system isn't a clean one, it's an experienced, battle-hardened one. Now consider the environment of a space station. It is, by necessity, one of the most sterile places humans can exist. The air is filtered to an extreme degree, surfaces are constantly sanitized, and astronauts are quarantined before they even launch to ensure they aren't bringing any microbial stowaways. Studies have shown that even in this cleanroom environment, the human immune system seems to get lazy. T cells, the soldiers of the immune system, become less effective in microgravity. Dormant viruses like chickenpox can sometimes reactivate. Cosmo would be born and raised in this sterile bubble. He would never make a mud pie. He would never be licked by a dog. He would never breathe in the scent of rain on dry soil, which is filled with bacteria. He would never catch the flu from a classmate. His immune system's library would be almost completely empty. It would be a pristine, state-of-the-art security system with no software installed, no threat database, no memory of what an enemy even looks like. Bringing him to Earth would be an act of biological terrorism against his own body. The first breath of unfiltered terrestrial air, it would be a shotgun blast of millions of new microbes, pollens, and fungi. His immune system, with no training and no memory, would have two possible reactions, both catastrophic. It could either fail to recognize the threats, allowing a simple rhinovirus, the common cold, to replicate unchecked like a deadly plague. Or it could panic, identifying everything as a threat and launching a massive, systemic, all-out assault on his own body, a condition called a cytokine storm. He would, in essence, be allergic to the planet. The very air that gives us life would be a poison to him, triggering a fatal meltdown of a security system that never had a chance to learn the difference between a friend and a foe. We've gone through the checklist of failures, the brittle bones, the confused senses, the weak heart, the useless muscles, the warped eyes, the naive immune system. But the single greatest tragedy for our zero-G human isn't any one of these things. It's the sum of them all. It's the profound and inescapable psychological consequence of being a human consciousness trapped inside a body that is fundamentally incompatible with being human on Earth. Think about your own sense of self. It's intrinsically linked to your body. Without thinking how much effort it takes to lift a glass of water. You have an innate sense of your own momentum, your balance, your place in a room. This is called proprioception, your brain's constant, silent understanding of where its body is in space. It's the foundational software of physical existence. Cosmos software would be written for a different operating system. His brain's entire model of reality, its body schema, would be based on a life of weightless, effortless grace. He would have the mind of a bird, but on Earth, he'd be given the body of a slug made of glass. The psychological dissonance would be unimaginable. He would think he could simply reach for an object, but his atrophied muscles and brittle bones wouldn't respond as expected. He would feel like he should be able to stand, but his faulty vestibular system and rebellious heart would send him crashing to the floor in a dizzy, fainting heap. It's not just that he would be physically disabled. He would be living in a state of constant, profound betrayal by his own physical form. Every moment would be a reminder that his body, the only one he has, is a prison. A leaden, fragile, painful anchor in a world it was never meant to inhabit. He would be the ultimate alien. Not because he came from the stars, but because he would be alienated from his own species, his own planet, and most tragically, from his own skin. He would have all the dreams, thoughts, and consciousness of a human, but with a physical experience that's a unique and inescapable form of torture. He is the ghost in a machine that was beautifully designed for the void, and therefore catastrophically broken everywhere else. And that's our list. If you want to keep feeding your algorithm with more of this delightful nonsense, you know the drill. That subscribe button isn't going to click itself.